Hi, I'm Joseph from IT2102. Back again with another vlog. So now I'm gonna answer all the activities here in chapter 6, entitled Network Layer. This chapter focuses on the role of the network layer. It examines how it divides networks into groups or hosts to manage the flow of data packets within a network. It also covers how communication between networks is facilitated. This communication between networks is called routing. So section 6 has 1, 2, 3, 4, 5, 6, 6 sections. Section 6.0 Introduction. Section 6.1 Network Layer Protocols. Section 6.2 Routing. Section 6.3 Routers. Section 6.4 Configure a Cisco router. And Section 6.5 Summary. So now let's start answering the activities. So to start, let's go to the first first section, 6.1.2.6. Here we go. So let's start. So activity IP characteristics. With each IP characteristics, then click connectionless, best effort, or media independent to indicate its delivery method. So no contact is made with the destination host before sending a packet. Its connections. So IP characteristic. Fiber optics, cabling, satellites, and wireless can all be used to the route the same packet. It's media independence. We'll adjust the size of the packet sent depending on what type of network will be used. So it's media independent again. So packet delivery is not guaranteed. So it's best effort. So we'll send a packet even if the destination host is not available to receive. So we'll send the connection and so on. Does not guarantee that the packet will be delivered fully without error. So best effort. Let's say it's correct, all correct. So let's proceed to the next activity. Let's go to the 6.1.3. So activity part 1 IPv4 header field. So instruction which each IPv4 header for function and then click the IPv4 header field to which it belongs. So IPv4 header function, so commonly referred as hop count. So it's time to leave. So identifies the priority of each packet. What's the priority of each packet? So it's always set to 0100 for IPv4, so it's the version. Identifies the IP address of the sending host. So it's source IP address. So IPv4 header functions identifies the IP address of the recipient host. Recipient host is the destination IP address. So IPv4 header function identifies the upper layer protocol to be useless. It's all correct. So version always set to 0100 for IPv4. Time to live commonly referred to as hop count. Source IP address identifies the IP address of the sending host. So differentiated services identifies the priority of each packet. Protocol identifies the upper layer protocol to be used next. Destination IP address identifies the IP address of the recipient host. And yeah, that's all about the activity IPv4 header fields. So let's proceed to the next activity. Next activity is in 6.1.4.6. 6.1.4.6. So here it goes. So select the previous activity. Activity IPv6 header field. So with each IPv6 header description, and then click the IPv6 header field to which it belongs. These are the descriptions. So the first description is when this value reaches 0, the sender is notified when the packet is not delivered. So when the sender is not delivered. Identifies the application type to the upper layer protocol. So it's next. Suggests that all packets receive the same type of handling IPv6 router. So it's flow label. IPv6 header of description, it's always set to 0110, so it's the version. Identifies the size of data portion of the packet. So it's payload. IPv6 header description classifies packets for congestion or growth, so it's traffic class. So here are the IP header fields and its description. So version is always set to 0110. Traffic class classifies packets for congestion control. Flow label to suggest that all packets receive the same type of handling by IPv6 routers. Payload length identifies the size of data portion of the packet. Next header identifies the application type to the upper layer protocol. Hop limit, when this value reaches 0, the sender is notified that the packet was not delivered. And yeah, that's all the activity about the IPv6 header field. So let's now proceed to the next activity. The next activity is on 6.2.2. 6.2.2.8. So let's first this one. So activity, identify elements of a routing table entry. This is the routing table entry A, B, C, D, E. So instructions, a partial router routing table entry is shown. Each section of the entry is identified by a circled letter above it. Select the correct routing table entry section for each output. Number 1. The elapsed time since the network was discovered. So it's the administrative distance and metric to reach the remote network. How the network was learned by the router. Let's see. Show the destination network. The next hop IP address to reach the remote network. So it's and last one is the outgoing interface on the router to reach the destination network. Let's check it. And yeah, that's all correct. So that's all about the activity. Identify elements of a router routing table entry. So now let's proceed to the next activity. Next activity is in the section 6.3, topic 6.1, 6.3.1 and page 6.3.1.7. So activity, descriptions of router functions and hardware parts. Instruction, descriptions of router functions and hardware parts are provided in the table. Drag each router component name to each function/description. So these are the names and these are the descriptions. So connects router to external networks usually over a large distance. So it's one interface. A way to remotely access the CLI across network interface. So Telnet or SSH. Connects computers, switches, and routers for internal networking. So it's that interface. A local port which uses USB or low-speed serial connections to manage network devices. So it's console. A port to manage routers using telephone lines and modems. It's AUX port. It's AUX port. Check. And yeah, so let's discuss the one interface. Connects routers to external networks usually over a large distance. Telnet or SSH, a way to remotely access the CLI across a network interface. LAN interface, connect computers, switches, and routers for internal networking. Console port, a local port which uses USB or low-speed serial connections to manage network devices. Lastly, AUX port, a port to manage routers using telephone lines and modems. So that's all the activity about the descriptions of router functions and hardware parts. So now let's proceed to the last and final activity in chapter 6. And it's on the same section 6.3.2 topic and page 6.3.2.6. What's that? So activity, the router boot process. This is about the boot process of the router. So instruction, drag each of the steps on the left to appropriate field in the table on the right to show the router boot process order. So these are the orders. So these are the so let's get answer this. So step 1 is perform post. Step 2 is load the bootstrap. Step 3 is load iOS. And step 4 is load the featured file. And yeah, it said that you have correctly listed the order of them. So this is the router boot process. For step 1, perform post. Hardware check performed by built-in ROM chip. So step 2, load boost bootstrap copied from ROM to RAM. Locate the iOS. So step 3, load the iOS operating system file for the router loaded into RAM. After bootstrap, find the iOS file to be used. So, last step is the load the configuration file from Flash TFTP server or go in a setup mode to create a configuration file. And yeah, that's all about the last activity in chapter 6. And yeah, we're done answering all the activities in chapter 6. To get familiarized to the chapter, just read and answer the activities again and again. And chapter 6 really focuses on the role of the network. The activity tackles about the IP characteristics, IPv4 header fields, IPv6 header fields, elements of a router table entry, description of router functions and hardware parts, router boot process. And those activities is very helpful to test our knowledge, and it's good for us to help us to be ready to chapter test exam. So that's all for chapter 6. Thanks for watching. Till next time.